In this tutorial, we have an exercise related to basicity. The exercise asks us, arrange the following in order of increasing basicity. Let's start from the first option. In the first option, we have methylamine, we have protonated methylamine and methylamide. Okay, let's now discuss which one will be the most acidic, which one will be the least acidic or basic. Okay, if we write the first one, we have methylamine and ammonia here, it has one lone pair. And in the methylammonium ion, we have an ammonium ion here, and nitrogen is positively charged. There is no lone pair. And the last one, we have the amide form. We have just one hydrogen and two lone pair, and there's a negative charge. There are two ways to solve this problem. Let's use the easy way first. The definition of basicity is basically ability to donate electron pair. And if we look at the second molecule, ammonium ion, it doesn't have any lone pair to donate. Or there's another definition for the basicity. According to Bronsted-Low rate theory, a base is a molecule that accepts hydrogen ion, right? So this molecule cannot accept any more hydrogen ion because nitrogen has already 4 bonds. So we cannot add any more hydrogen. So let's say this is A, B, and C. B will be the least basic one. And if we compare A and C, C will be more basic because it has 2 lone pairs to donate, or it can accept 2 protons. But A can only donate 1 electron pair, or it can only accept 1 hydrogen ion. So for that reason, we will say that B is the least basic, then A, then C. The second way to solve the problem, checking the conjugate acid pKa. Okay, let's look at the conjugate acid forms. For the first one, for the A, let's write it here. The conjugate acid form is the protonated form, which is this one. And for the B, we cannot have any conjugate acid form because we cannot add any more hydrogen to the nitrogen. So there is no such concept for conjugate acid of B. But for the C, the conjugate acid will be the protonated form, which is going to be the amine form. And we know that protonated amines, they have a pKa of 9 to 10. And for the neutral amines, the pKa is around 36. So which one is more acidic? Protonated amine or this one? So less pKa means more acidic. So this is going to be more acidic, and this will be less acidic, the protonated form or the conjugate acid. If your conjugate acid is more acidic, means that you are less basic, the base form. This is less basic. And if your conjugate acid is less acidic, it means that you are more basic. That's the reason why C is more basic than A. But as we discussed, for the B, we cannot discuss conjugate acid pKa concept because B already has maximum number of bonding. It cannot accept any more hydrogen. Okay, that's for the A. For the B, we can use the same concept, But let's just erase some parts so we can discuss the solution. Let's also clean this part. We may need it. Okay, for the B, let's write here B. I'm going to use the second approach. The approach is, let's say this is A, B, C. Out of these three molecules, which one is more basic, which one is less basic? So the first one is methoxy, the base, and its conjugate acid form is methyl alcohol, methanol. And for the second one, it is methylamine, the conjugate acid form. And for the third one, if we just add a hydrogen, it's going to be ethane, alkane. So let's write what kind of functional groups we have. We have an alcohol, we have an amine, and we have here an alkane. And from pKa tables, you can easily find the pKa values of alcohols as 16 to 17 range. For the amines, the pKa is around 36, and for the alkane, the pKa is around 50. So if we check the pKa of the conjugate acid forms of these anions, the last pKa means more acidic. So this is the most acidic, and alkane is the least acidic, meaning that if your conjugate acid is the most acidic, means that you are the least basic. So A will be the least basic, and the alkane C, the alkane is the least acidic, meaning that its base form or conjugate base form will be the most acidic, the most basic. So if we just do from the least to most, A is the least, then B, then C. C is the most basic, A is the least basic. Okay, B is finished. Let's come to C. Again, I'm going to use the second approach, which is the conjugate acid strength. In the books, we have always pKa tables, so it is advisable to use the pKa values of the conjugate acid forms, then decide which one is the least basic and which one is the most basic. Okay, the first one is if we add a proton, a hydrogen here, so we will end up with an alkene. So the conjugate acid, let's write conjugate acids will be, for this one, the first one, let's say this is again A, B, C. A's conjugate acid is an alkene, and for the B's, if I add a hydrogen, a hydrogen ion, it's going to be an alkane, CH3, CH2, and CH3. So let's write here alkene, the first one. The second one is an alkane. The first one, definitely, if we add a hydrogen, and it's going to be the neutral acid form, CH3C triple bond CH. So this is an alkyne. From the tables, from the pKa tables, you can find that the pKa of an alkane is around 40, 42s, and alkane, the pKa is around 50, and alkynes are the most acidic out of these three species. The pKa will be around 25. So the most acidic, so out of these three conjugate acid, Alkyne is the most acidic because it has the lowest value of the pKa, and alkane will be the least acidic. After that, we can decide their conjugate base form. So the most acidic one's conjugate base will be the least basic. So C will be the least basic. And alkane is the least acidic, so its conjugate base form will be the most basic. So C is the least basic, then A, then B. Okay, I think we've finished all the options. Thank you so much for watching the video.